our next section, we're kind of going outside of the book a little bit. I guess chapter 13, we kind of do some of the things in the book, but in a different way from what our book does. So anyway, our next little bit here, we are going to look at the 6 trigonometric functions. Now, reviewing a little bit from things that you've learned in geometry. In geometry, you learned that there are 2 types of special right triangles. And if you have a special right triangle, the sides are always in these ratios. 45, 45, 90 right triangles are in the ratio 1, 1, square root of 2. For example, you could have a triangle, and you could have a right triangle who's a 45, 45, 90. These 2 legs are congruent. If this was like 3, this other leg would be 3, and the hypotenuse would be 3 square root of 2. And same thing with a 30, 60, 90. In your 30, 60, 90 triangle, your shortest side is opposite the smallest angle. Remember that. Shortest side is opposite the smallest angle. And then the square root of 3 is opposite your 60-degree angle. Your hypotenuse, the longest side, is the biggest number. A lot of times people get the 2 and the square root of 3 mixed around. Well, square root of 3 has to be less than 2 because the square root of 4 is 2. So hopefully that'll help you a little bit. But the same idea, sides are always in these ratios. So you could potentially have a 30, 60, 90 triangle whose short leg is 4. The long leg would be 4 square root of 3. And the hypotenuse is twice the length of the short leg. So it'd be 8. Those are all possibilities. Now, using your geometry skills, can you find the sine of 60 degrees, the cosine of 30 degrees, and the tangent of 45 degrees? Hopefully you remember from geometry this little acronym, SOH-CAH-TOA. If you remember SOH-CAH-TOA, this means that the sine of an angle equals the opposite over the hypotenuse. Okay. And this symbol here is theta. It represents an angle. So the sine of an angle equals the opposite over the hypotenuse. The cosine of an angle equals the adjacent over the hypotenuse. And the tangent of an angle equals opposite over adjacent. Hopefully that kind of rings a bell. And then using those skills, using that acronym, SOH-CAH-TOA, we can figure out all of these 3 problems. So the sine of 60 degrees, look at our 60-degree angle here and our special right triangle. Sine is the opposite over the hypotenuse. So looking at my 60-degree angle, my opposite side is straight across here, the square root of 3. My opposite is the square root of 3. Opposite over the hypotenuse. Hypotenuse is always opposite the 90-degree angle. So my hypotenuse is 2. Well, cosine of 30 degrees. Cosine is adjacent over hypotenuse. My 30-degree angle here. My adjacent has to be one of these 2 sides. Adjacent means we're next to it. So are we next to the 1? No, we're not next to that. But we're next to the square root of 3. over the hypotenuse is 2. And then the tangent of 45 degrees is opposite over adjacent. Well, let's look at our 45-degree angle here. My opposite side is 1. The adjacent is 1. 1 over 1 is 1. Okay? So hopefully this helps you remember how those special right triangles work, and also SOH-CAH-TOA.